In this problem, we are given a mass m, which is connected by two strings to an axle. And the whole thing is rotating with a frequency omega. We know the length of each string, L, and we also know that as it rotates, these strings are making 45-degree angles with respect to the axle, and we also know the mass of the object M. The question is, what is the tension in each of these strings? So, to answer that question, let's first draw a free body diagram for the mass. So, free body diagram. So, here is the mass M. So what are the forces acting on it? Well, first, there is a gravity force, mg, pointing downwards. Then there is tension, and let's call this tension as tension 1. So tension in this string is going to be tension 1. And tension in this string is tension 2. The mass is making a circle around the axle, and so it has to have centripetal acceleration. The centripetal acceleration is pointing towards the center. So I'm going to draw it like this. This is my centripetal acceleration. So this is a free body diagram for the mass. Now, we can use the Newton's second law to write the two equations. Well, first of all, remember that if this angle here is 45 degrees, then on this diagram, this angle here is also 45, and this angle here is also 45 degrees. Let's introduce x and y axis. Let's say that this is x and this is y. So now we can write the Newton's second law, and let's start with the y-axis. So in the y direction, we have tension 1, which has a y component and is equal to T1 cosine 45, and is pointing in the positive y direction, so it's with plus. Then T2, but with a negative sign because it's pointing downwards, so minus T2 cosine 45 and minus mg. This is equal to mass times acceleration, but in the y direction there is no acceleration, so this is just 0. So this is what is happening in the y direction. So what about the x? Now let's look at x. So we have T1 sine 45, T1 sine 45, and then T2 sine 45. Both of them are in the positive x, so T2 sine 45. And g has no x component, so this is equal to mass times centripetal acceleration AC. So now we have two equations and two unknowns, T1 and T2, and we can calculate for each tension. We're going to need one more piece of information. Remember that centripetal acceleration AC can be written as v squared over r, where r, and I should draw this picture once again, so r is this distance. Okay? So this is r. Remember, we are given L, but we are not given r. Well, we also know this angle 45, so we can make a connection there. We can say that r is equal to L sine 45, or L divided by square root 2. So let's first notice that sine and cosine of 45 are the same. So this thing is equal to this thing, because sine 45 and cosine 45 are both 1 over square root 2. So I can take this thing from the first equation and plug it in here. So let me write this in here. So R is equal to L over square root 2. We will need it. So this T1 sine 45 is equal to T2 times cosine 45, or T2 square root 2, plus mg, plus this T2 sine 45, so T2 square root 2 equals m times AC. So m v squared over r, and r is equal to L over square root 2. So we can simplify this now. So if you simplify this, you get T2 equals mv squared 2mv squared over L minus mg square root 2, and the whole thing is divided by 1 over 2. So we have two T2s here. So then this is equal to mv squared over L minus mg square root 2. Remember also, we are not given V, but we are given omega. How can we relate V to omega? Well, we know that V is equal to omega R, or omega L square root 2. So let's use this in this equation. So we have m over L, V squared is omega squared, L squared over 2 minus mg square root 2. So this can be simplified. So I'm going to say that this is equal to mg over 2, mg over 2. So this L cancels this L. So I have omega squared L over g minus square root 2. So this is the final answer for tension 2. So we can write it down here. And g over 2 omega squared L over g minus square root 2. Now, when you know tension 2, you can calculate for tension 1, for example, from this equation. I'm going to leave this up to you because this is just algebra, there is no physics involved. And I will just write down the final answer, which happens to be mg over 2 omega squared L over g plus square root 2. So symmetric to it. And that's the final answer.